Good morning, y'all. For you, this is Friday morning. Our lecture today is going to be on rational inequalities, but I want to start with prayer. A couple of prayer requests were uploaded yesterday to LMS, so let's start with those. If y'all bow your heads and pray with me. Dear God, I thank you for today. I thank you for this opportunity to learn by distance. Lord, I pray for everyone that's in the sound of my voice, be they my students or someone who's accidentally uncovered this on YouTube. I ask you, Lord, just to take care of them in this time of chaos, and we ask you to eradicate the coronavirus, Lord, from our country and our world. We know that you are the great physician, and we ask you to do that. Lord, we lift up to you Ceresa's request for baby Kyler and his mom Mandy. I just pray, Lord, that you will work in that situation. You know what needs to happen, and I lift it up to you. I pray for my Gracie as she's traveling by herself today to NC State, Lord, because they've canceled classes for the rest of the semester. So, Lord, I just ask you to keep her safe as she travels down there and as she travels back. And, Lord, you know she wanted to go by herself because she's sad over the losing basically 1/4 of her freshman year. So, Lord, I just ask you to take care of her today, keep her safe, and put a hedge of protection around her car. Lord, for anything else on people's hearts they're listening, I lift them up to you, knowing, God, that you go before us and you've already heard. Please now bring understanding to those who are struggling and help to make today's lecture clear and understandable. In the precious name of Jesus we pray. Amen. Okay, guys, in your packet, if you looked at problem number 120, it says rational inequalities. That's what we're doing today. I uploaded you a PDF. It is 4 pages long, and it says something about study guide and practice, rational inequalities, something to that effect. The first page is rational equations, which we've already done. The second page is rational inequalities. That's where we're starting today. The page number that you'll see on the PDF is page 548, and there is an example at the top, and it looks like this. That's where we're going to start. I would ask you to take some notes. If you want to print out that PDF and write it up, you can. This example is written there. It looks like this. Okay. So we're going to do the first example at the top of the page, then we're going to work a few more example problems, and then your homework will be selected problems from that PDF. So we have a rational, it's rational because these are fractions, inequality because we have a less than or greater than sign. If you look on the notes, there's a 3-step process. The first step is state the excluded values. We're going to talk about that. Then pretend it's an equation and solve it. Use the values from steps 1 and step 2 to divide a number line into regions, and then we're going to test each region. So that's our process. All right, so first, excluded values. Excluded values are anything that make the denominator 0. So from here, 3n, the only thing that would make 3n equal 0 is if n equals 0. From here, 5n, the only thing that would make this 0 is 0. This one doesn't have a variable, it just has a 3, so there's nothing excluded. So this is step 1, excluded values. Step 2 said solve it like it was an equation. So I'm actually going to write it out as an equation. To solve a rational equation, you find the least common denominator. So I need the smallest thing that 3n, 5n, and 3 go into. Well, 3 goes into 3n, so this is already taken care of when I take care of this one. The smallest thing that 3n and 5n both go into is 15n. Because an n will go into an n, 3 goes into 15, 5 goes into 15. Put brackets around the whole problem. We are eliminating the denominator. That's how you solve rational equations. You eliminate the denominator. Okay, so I put 15n out in front, and it's really 15n over an understood 1. Then I look at what or how many times this goes into that, or what extra you would need to multiply this by to get that. Well, 3 goes into 15 5 times. I need an additional 5. Okay, I've got the n. Basically, the n's are canceling. 3 is going into 15 5 times. 5 times 2 is 10. And now there's no denominator. Let's do the next part. 5n goes into 15n 3 times, and 3 times 4 is 12. Again, no n because it canceled. 3 goes into 15n 5 times, but you need an n too because there's not an n to cancel. 3 goes into 15 5, so we've got 5n. So you're thinking, what's canceling here is everything except a 5. What's canceling here is everything except a 3. What's canceling here is a 3 into there, which is leaving me with 5n times 2 is 10n. Now I have a pre-algebra equation. 10 plus 12 is 22 equals 10n. Divide both sides by 10. Now I see that on the worksheet they actually give you a decimal. I'm going to give it to you both ways, a decimal and a fraction. 22 divided by 10 reduces to 11/5, or that is the decimal 2.2. So this whole thing right here is step 2. Solve the equation. Step 3. Use the values from step 1 and step 2 to divide the number line into regions. So draw a number line. Guys, whenever you have an inequality, you have number lines. So draw a number line and put the excluded value on it. So that's 0. Put the answer that you found, which is 2.2, on the number line. Now, we have 3 regions, okay? We have 3 regions. We're going to test here, we're going to test here, we're going to test here. But first, I'm going to put open or closed circles. 0 was excluded. It has to be an open circle. You can't use 0 because it would make the denominator 0, which is bad. Okay? 2.2 is an answer. This has an underbar under it, so it means less than or equal to, so it can actually include 2.2, so I'm making it closed. If this wasn't here, 2.2 would be open. Okay? Now, we're going to test here, here, and here. So let's pick something obvious. So to test down here, I'm going to test -1. To test in here, I'm going to test +1, because that falls in there. To test out here, I'm going to test 3. Now when I say test, I mean plug it back into the original and see if it's true. Alright, so here's the original. 2 over 3n. 3 times -1 is -3, plus 4 over 5n. 5 times -1, which is my test. Oh, there it is. 5 times -1 is -5. And the question is that less than or equal to 2/3? Now guys, I'm not going to do the math. I'm going to use common sense. This is a negative number. A positive divided by a negative is a negative. This is a negative number. Positive divided by a negative is a negative. A negative number plus a negative number is a negative number. I don't care what it is. It's just a negative number. A negative number will always be smaller than positive 2/3. So this is true. Good? A negative number will always be smaller than positive 2/3. Why work this out and get a common denominator and all that mess if you know it's to be true already? So, good test taking skill. Alright, now let's test 1. So, coming back up here, 2 over 3 times 1 is 2/3. 4 over 5 times 1 is 4/5. And the question is that less than or equal to 2/3? Again, use common sense. I've got 2/3 and I'm adding something more to it. So I've got a positive and I'm adding more to it. And the question is it less than 2/3? Well, you had 2/3, you added something to it. It's obviously more than 2/3. So now this is false. Okay. Now I'm going to test 3. Guys, don't get lulled into the habit of thinking it always goes true, false, true, or false, true, false, because it may not. So we're going to test 3. 2 over 3 times 3 is 9, plus 4 over 5 times 3 is 15. And the question, and I'm putting a question because I don't know, is it less than 2/3? I'm going to have to get a common denominator here because I've got to have to compare everything to see. So the smallest number that 9 and 15 and 3 go into, well, 9 and 15 both go into 45, and 3 goes into 45, so I'm going to change everything to 45s. Nine times 5 is 45, so 2 times 5 is 10. 15 times 3 is 45, so 4 times 3 is 12. I'm multiplying by what we call a fancy 1, right here. 3 times 15, oh, you can't see it, let me slide it over. 3 times 15 is 45, so 2 times 15 is 30. So the question is 10 45ths plus 12 45ths, is that less than 30 45ths? 10 plus 12 is 22. 22 45ths is indeed less than 30 45ths, so that is true. So now the question is, how am I going to write my answer? Okay, I can show my answer on the number line. So I shade where things are true, so it would be that and that. I can write my answer with less than signs. Remember, we've written our answer 3 ways. A number line, then with less than or equal to signs. So not x, it's n. Let's try again. N is less than 0, or n is greater than or equal to 2.2. We can write our answer that way. Or we can write our answer in set notation. Now, if you were taking this class at our local community college, they require it in set notation. So I read from left to right, negative infinity to 0. It doesn't include 0, so that's a parenthesis. You can't put God in a box, so that's a parenthesis. The or is a union symbol. Then 2.2 is included, so it's a bracket, and it goes all the way to positive infinity. So when you do your homework for me tonight, your answer can be written that way, or the number line. I've got to see one of them, okay? So we just did one example. We're going to do quite a few more. But right now what I want you to do is I want you to pause the video, and I want you to rework this example on your own without looking at your notes and see if you can get it, and then restart the video. Okay, hopefully you did that. If you didn't do that, on you. Okay, on that same page, 548, I want to do another example, and then we'll probably do one more example, so we'll have 3 examples. Okay, I'm going to do on that same page, 548, problem number 6. 3 over x squared minus 1 plus 1, I'm going to go ahead and put it 1 over 1 so that you can see, is greater than 2 over x minus 1. Now those of you that have been struggling with solving rational equations, here's going to give you a good example of how to solve a rational equation again. So in solving a rational equation, you always factor the denominators first. So let's look here and see how we're going to factor this. This thing is a pattern y'all should recognize. I call it DOPS. For those of you that are listening that aren't in my class, that's difference of perfect squares. That's a square and that's a square. So to factor squares, factoring is breaking it out. X times x gives me x squared. 1 times 1 gives me 1. That's why it's a difference of squares. X squared is a square and 1 is a square. 1 plus, 1 minus. Okay, that's factored. Nothing to factor there, nothing to factor there. So step 1, excluded values. Excluded values are anything that make the denominator 0. x from here cannot be negative 1. Now really I probably should write x can't be negative 1. I've just been writing x equals negative 1, but I've written the word excluded. So what I'm telling you is, if that's your answer, it's bad. All right, from here, x minus 1 equals 0, so x equals positive 1. Or doesn't equal positive 1, however you want to think about that. Okay? So there's my two excluded values. Step 1. All right. Can you hear the familiar sound of Diet Coke being opened? Step 2. Solve it like it's an equation. So I'm going to write it in its factored form as an equation. I'll put brackets around the whole thing, and I'm going to find the least common denominator. Every bit in the denominator has to be represented. The 1 is irrelevant. I got to have an x plus 1 as part of my least common denominator, and I have to have an x minus 1 as part of my least common denominator, so that takes care of this one. 1 is already taken care of. This x minus 1 is taken care of by that x minus 1. So there's my least common denominator. Okay? Now I am distributing the least common denominator through and canceling where appropriate. So here, that cancels that cancels that, and all that's left is a 3. Does that make sense? You're multiplying by this fraction, x plus 1, x minus 1 over 1. Those cancel those, and they're gone. So all that's left is a 3. Now here, the 1 doesn't cancel anything. There's a 1 up there. I'm writing it for giggles and grins. It's irrelevant. If it was a 2, it would be relevant, or any other number. 1 doesn't cancel anything, so both pieces come along for the ride. Okay? Now this last piece, that x minus 1 cancels that x minus 1. So I've got the 2 that was up there, which is relevant, times the x plus 1 that didn't get canceled. Good? Let's go through that again. Both of these canceled both of those, so I was left with a 3. Nothing canceled here, so I have both of them. X minus 1 canceled x minus 1, so I've got to have the 2 and the x plus 1. Now I'm going to do math. Excuse me. All right, so let's FOIL this out. Now guys, use common sense. We know what it is FOILed out because we unfoiled it. And timesing it by 1 doesn't change anything. Here we distribute. Good? Now, it's an x squared, which means it is a quadratic equation. So we have to get everything equal to 0. So I'm moving all of this over there, and I'm going to combine like terms. So I only have 1x squared. Okay? Positive 2x, when I move it over here, becomes negative 2x, and there were no plain x's over here. Okay, now let's see what else I had over here. I had a 3 minus 1, which is a 2. And when I move this 2 over, 2 minus 2 is 0. This is 2. When I move this positive 2 over, it becomes a negative 2, and it cancels. So now I have this. X squared minus 2x equals 0. Quadratic equation. I factor it by GCF. The GCF of these two, greatest common factor of these two, is x. So I pull it out. X out of x squared is x. X out of negative 2x is negative 2. Again, this is why I told y'all you can't do this chapter that we're on if you don't know how to factor. All right, baby equations. What value am I going to get from here? It's an x all by itself. X equals 0. My value is 0. What value am I going to get from here? X minus 2 equals 0, so x equals 2. Okay. Step 1, find the excluded values. Step 2, solve the rational equation and get your answers. Step 3, draw a number line. And we got lots of bits to put on this number line, which is why I chose to do this one. I need negative 1. I need 0. I need positive 1. And I need 2. I have 1, 2, 3, 4, 5 different test areas. Okay. Now, let's think about whether they're open or closed circles. -1 and 1 must be open because they're excluded values. 0 and 2 are answers, but it says greater than, so they are open as well. We good so far? Now, grab your calculator, because we're going to test these using our calculator. Okay? So first thing we got to do is figure out what we're going to test. So out here I'm going to test -2. Here I'm going to test -1/2. I'm going to put -0.5. Okay? Here I'm going to test +0.5. Here I'm going to test 1.5. Here I'm going to test 3. I'd rather test a whole number than a rational number if I can help it. Okay? Now, the way we're going to do this is we're going to use the store feature on our calculator, and we're going to type the left side and the right side and compare them. So if you will watch me, you'll see my calculator rhythm. I'm starting by testing -2. So -2 store is right here, store is right there, as x. Enter. So right now my calculator thinks -2 is x. I want to type this. I'm using an old calculator so I can show you parentheses. So my numerator is 3. These are extraneous parentheses, but I'm putting them so y'all get in the habit. Put the numerator in parentheses, divided by, put the denominator in parentheses, x squared minus 1. That's the whole first term. Now, those of you with the new fancy calculators can use alpha and the y equals and make the little fraction thing pop up and not use the parentheses. I'm doing it on an old calculator so you can see it. So that's the first part, then plus 1. Calculator does order of operations, so it's going to divide this, then it's going to add 1, hit enter, and I get the decimal of 2. I'm going to write that down so I don't forget it. Okay? Now, let's do the right hand side. Numerator in parentheses. You don't need those, but sometimes y'all don't know when you need them and when you don't, so I'm using them so that you won't get in the habit of not using them. Here's the whole denominator. If you don't put the denominator in parentheses, you will not get the right answer. And I get -0.66 repeating. And it said greater than. 2 is greater than -0.666 repeating, so that is true. Good? Now, I'm going to show you a shortcut. I'm not going to type all this mess again because your calculator will save you from doing it. So I need to test -0.5, but I have to put that in. -0.5, store as x. Whoops, I hit the store button twice. Enter. Now, I don't want to type this again. So use second and entry and don't hit enter until that line pops up on your screen. There's the line. When I hit enter, it's going to calculate based on the -0.5, and I get -3. So let me write that down. Now I want to do this one. Second entry, second entry, second entry, till it pops up. Hit enter, and I get -1.333. -3, and now remember my original sign was greater. -3 is greater than -1.3. That is false. Good? All right, let's test 0.5. 0.5, store as x. Now guys, you could test these by hand, but I'm saving you a significant amount of time. Second entry, second entry, second entry. There's the right or the left-hand side. And I get -3. Now, second entry till I get to the right-hand side. There that is. And I get -4. -3 is greater than -4. Is that true? -3 is greater than -4? Yep, that's true. Good. I'm going to test 1.5. 1.5, store is right here above the on key, as x. I get, it shows me 1.5, second entry, second entry, second entry, till I'm back to the left-hand side, and I get 3.4. Now I got to go to the right-hand side, second entry, second entry, second entry. There's the right-hand side. I get positive 4. 3.4 is greater than 4. That is false. Last one to test. Test 3. 3, store as x. Second entry, second entry, second entry. There's the left side. And I get 1.375. Second entry, second entry, second entry. There's the right-hand side. I get 1. 1.375 is greater than 1. That is true. Okay. Lay my calculator aside. Now, let's shade the true. So we have here. We have here. We have here. Okay. Now, let's write it with symbols. So to write this with symbols, x, yep, it is an x. X is less than -1, or to write this with symbols, we make a sandwich. 0 is less than x is less than 1. X is between 0 and 1. Okay? To write this, there's another or, x is greater than 2. Okay, we can write it that way. Long answer. Or let's write it in set notation. We read from left to right, negative infinity to -1, all parentheses, union, or means union, 0 to 1, parentheses, union, 2 to infinity. For your answer, I will accept this. As long as I can see what's shaded and what's not, open and closed, this or this. Okay? I'm going to stop this video. I would like you, this is part of your homework, you will be doing part of your homework as you watch the next video. I would like you on page 548 to do problems 1, 2, and 3, and then watch the next video link to see if you got them correct. Again, problems 1, 2, and 3. Thank you.